Division of radical expression. In math, a radical expression is defined as any expression that contains a radical symbol. It uses a root such as square root, cube root, and more. So to perform division on radical expressions, there are 3 steps to follow. Step 1. Convert the expression to similar radicals. To convert, first, change the expressions to rational. Next, express the exponents as similar fractions, and then change the expressions back to radical form. Step 2. Step 2 is to apply the quotient rule. The quotient rule states that the quotient of 2nth root is equal to the nth root of the quotient. Step 3. Step 3 is to rationalize and simplify the expression. Let's have some examples. Simplify square root of 35x over square root of 7x squared. Following the steps, first let's do step 1. Convert the expression to similar radicals. But as we can see, the radicals in the expression are already similar, so let's proceed to step 2. Step 2 is to apply the quotient rule. Again, the quotient rule states that the quotient of 2nth root is equal to the nth root of the quotient. So, square root of 35x over square root of 7x squared will become square root of 35x over 7x squared. Then, divide. Square root of 35x over 7x squared is equal to square root of 5 over x. Now, let's do our third step. Rationalize and simplify the expression. Square root of 5 over x is just equal to square root of 5 over square root of x. Now let's do rationalization. Rationalization means the process of removing the radical symbol in the denominator by multiplying both the numerator and the denominator by a radicand that will make the denominator a perfect nth power. So now let's multiply square root of x to both numerator and denominator, and it will become square root of 5 over square root of x times square root of x over square root of x. Square root of x over square root of x is just equal to 1. We did not alter anything because anything that is multiplied to 1 is just equal to itself. Now let's multiply, and it will become square root of 5x over square root of x squared. Then simplify, and it will become square root of 5x over x, and that will be our answer. Let's have another example. Cube root of 2z over the fourth root of 2z. First, let's do step 1. Convert the expression to similar radicals. First, let's change the expression to rational, and it will become quantity of 2z raised to the power of 1/3 over the quantity of 2z raised to the power of 1/4. Next is to express the exponents as similar fractions, and this will become quantity 2z raised to the power of 4 over 12 over the quantity 2z raised to the power of 3 over 12. And then change the expression back to the radical form, and this will become 12 root of quantity 2z raised to the power of 4 over 12 root of quantity 2z raised to the power of 3. Now let's proceed to our second step, which is to apply the quotient rule. Again, the quotient rule states that the quotient of 2nth root is equal to the nth root of the quotient. So, the 12 root of the quantity 2z raised to the power of 4 over the 12 root of the quantity 2z raised to the power of 3 is just equal to the 12th root of the quantity 2z raised to the power of 4 over quantity 2z raised to the power of 3. Applying the laws of exponents, and this will become the 12th root of the quantity 2z raised to the power of 4 minus 3. Then, let's simplify, and this will become 12th root of the quantity 2z. 12th root of the quantity 2z is already in simplest form, so this would be our final answer. Let's have our last example, which is 2x over 3 plus square root of 7. As you can see, our last example is different from our first two examples because the denominator is a binomial. Note, to simplify a fraction whose denominator is a binomial containing radicals, multiply the numerator and the denominator by the conjugate of the denominator. So, let's do the conjugation process. Conjugation means the process of multiplying a binomial by another binomial which was formed by negating the second term of the original binomial. So let's multiply the numerator and the denominator by the conjugate of our denominator 3 plus square root of 7, which is 3 minus square root of 7. So this will become 2x over 3 plus square root of 7 times 3 minus square root of 7 over 3 minus square root of 7. Now, let's do multiplication of binomials, and this will become 2x times the quantity of 3 minus square root of 7 all over quantity of 3 plus square root of 7 times the quantity of 3 minus square root of 7. And then, 2x times 3 minus 2x times square root of 7 all over 3 squared minus square root of 7 squared. And then, let's simplify. And it will become 6x minus 2x square root of 7 all over 9 minus 7, which is equal to 6x minus 2x square root of 7 over 2. This is not yet in simplest form, so let's factor out 2, which will become 2 times the quantity of 3x minus x square root of 7 all over 2. 2 over 2 is equal to 1. So this will become 3x minus x square root of 7. And this would be our final answer. Now, try this. Check if you got the correct answer.